Good day to you all. Welcome to the third in Vibrant Health series of educational webinars designed to broaden your understanding of health and nutrition. Let's start today's webinar with a little vignette set in a time 12,000 years ago. We are looking in on a post-glacial landscape in what will one day be Europe. It is late spring or early summer. The men had separated from the clan in the early morning to scout along the river flowing south. They were looking for big game, perhaps water buffalo, that they presumed would be watering along the route. Younger women and girls were foraging over the slopes and among the trees on the western edge of the river, while the bulk of the clan migrated more slowly behind them to new hunting grounds. As the foragers came to a glen through which traversed a tributary to the river below, the group spied a lush plant with drooping leaves and tiny blue blossoms tilting out over the edge of the little stream. It was a new plant none of the young ladies had ever seen before. The leaves looked soft and tender. Did they dare to eat them? Questioning looks from 5 girls to the 6th, more senior young woman among them, yielded no confirming nod of the head, but rather a blank look punctuated by raised eyebrows. She, Bolomir, the eldest, did not know whether this plant would be food or poison. Nahemi, the youngest among the group, impulsively but gingerly picked 2 leaves and ate them, grinning first at the satisfaction and then gritting her teeth with a shiver at the pungency of the leaves playing along the nerves in her jaw muscles. Bolomir scolded her nevertheless, and then picked a healthy bunch of stems and leaves to take back to the clan to seek consultation from the elder women. Later, before nightfall, the full clan regathered among the tall grasses of the lush floodplain neighboring the river. The men had been successful in just that one day. They had encountered 5 water buffalo at a pool in a shallow area of the river and were able to slay one of them. The women and girls who had foraged over the ridges had returned with baskets of flowers, edible plants, and some late summer berries in addition to the curious bunch of stems and leaves from the new plant. Several older women examined the stems and leaves of the streamside herb. They called Nahemi to them to ask her about her experience of eating the leaves. Her response was unintelligible, however, for her tongue was swollen and her lips were inflamed and sore. All this from just 2 leaves. The decision was made. This was not a food to eat. Nahemi was given a decoction of elderberry leaves and a mush of pounded, raw water buffalo tongue to hold in her mouth. She was to sit by the river with her head bowed, slowly letting the mixture of saliva and water buffalo tongue mash trickle soothingly out her mouth, over her lips, and into the stream. The clan was determining what foods could sustain them as they migrated into a new region of Europe. It would do them no good to eat foods that made them sick, or possibly even killed them. Nahemi had an allergic reaction 12,000 years ago. Yet, after all this time, we are still sorting out what foods we should eat and what foods we shouldn't. What makes the question all the more intractable is how differently we all react to the same food. My brother can have allergic reaction to cheddar cheese, for example, yet I don't. So, what is an allergic reaction? An allergic reaction occurs when the immune system overreacts to what should be a harmless substance. It is called an allergen. The immune system protects your body from infections, viruses, and diseases. In some people, substances such as pollen, certain foods, latex, mold, pet dander, dust mites, or insect stings are allergens that trigger the production of antibodies called immunoglobulin E. These antibodies travel to cells that release a host of cell-to-cell messengers, the cytokines, that trigger inflammatory immune responses, causing symptoms that often seem mild. A drippy nose, itchy eyes, lung congestion, sore throat, stuffy sinuses or ears, digestive distress, or a skin rash. This common association of transient discomforts with the word allergy has created a false image of allergy as nothing more than a nuisance. But allergic reactions can range from mild to severe and include swelling, eczema, sneezing, asthma, abdominal pain, brain fog, amnesia, ill temper, somnambulism, decreased blood pressure, increased blood pressure, diarrhea, rapid pulse in all cases, and even cardiac arrest. Yes, allergic reactions can be mild, chronic, or deadly. The latter we refer to as anaphylaxis, a serious allergic reaction involving multiple parts of the body. The first time a person with an allergy is exposed to an allergen, it may not cause a reaction. However, the person may then become sensitized to the allergen so that even minor future exposures to the allergen produce an allergic reaction. 8 foods are responsible for more than 90% of food allergies. You have heard of them all before: cow's milk, eggs, soy, wheat, peanuts, tree nuts, including walnuts, hazelnuts, almonds, cashews, pecans, pistachios, fish and shellfish. All food allergies have the potential to cause potentially life-threatening anaphylactic shock reactions. The foods most commonly associated with anaphylaxis are peanuts, tree nuts, fish, and shellfish. Peanuts' relatives, soybeans, kidney beans, and other legumes, could probably be added to the list of the major 8 most allergenic foods, if only based on digestive distress as their hallmark allergic effect. As in this cautionary tale. In 1988, a hospital launched a Healthy Eating Day in its staff canteen at lunchtime. One dish contained red kidney beans, and 31 portions were served. At 3 p.m., one of the customers, a surgical registrar, vomited in theater. Over the next 4 hours, 10 more customers suffered profuse vomiting, some with diarrhea. All had recovered by the next day, thank goodness. No pathogens were isolated from the food, but the beans contained an abnormally high concentration of the lectin phytohemagglutinin. The whatin? The lectin. Proteins in these primary allergenic foods are usually the culprits, although resins and oleoresins can sometimes trigger reactions. Lectins are proteins. All the 8 or 9 primary allergenic foods are rich sources of protein and of lectins. One peanut, for example, contains about 200 milligrams of protein, 100 micrograms to 2 milligrams of which may initiate an allergic response. In other words, 100 micrograms to 2 milligrams of which may be lectins. At least 7 peanut proteins have been identified as allergens. Their ready ability to bind with immunoglobulin E, an antibody, sets off an extended immune reaction that defines the allergic response. But before we get carried away, and to be fair, not all lectins are bad. Lectins are a class of carbohydrate-binding proteins identified initially in plants more than 100 years ago, in 1888. We have now found them in all life forms, from protozoa up through plants and animals to the human body. A lectin molecule contains a minimum of 2 sugar-binding sites and may be found in mammals traveling the byways of the bloodstream or bound to cell membranes as glycoprotein, a sugar-containing protein. It is this ability to stick to things that can determine either the good or evil character of a lectin. Their binding ability is also reversible, so that once made, a junction can be reversed under proper circumstances. In humans, lectins play many roles, both positive and negative. On the positive side, lectins help regulate cell adhesion, glycoprotein synthesis, and protein levels in the blood. Certain lectins on the surface of liver cells may also control the removal of certain unwanted glycoproteins from the circulatory system, acting somewhat like magnets or flypaper. A group of proteins that are essential to the proper function of our innate immune system, called complement proteins, just happen to be lectins too. For example, mannose-binding lectin recognizes carbohydrate patterns found on the surface of many pathogens, including bacteria, viruses, protozoal parasites, and fungi. The binding of mannose-binding lectin to D-mannose and L-fucose residues on the surface of many pathogenic microbes triggers the complement system of your innate immunity. This is the lectin pathway that turns on your immunity. In this way, mannose-binding lectin benefits us by inactivating or identifying bacteria, viruses, yeasts, and parasites, thereby setting them up for destruction. Figuratively speaking, mannose-binding lectin paints a fluorescent sign on the pathogenic microbe that announces, "Come and get me," to immunoglobulins and phagocytic cells, the white blood cells that engulf, eat up, and destroy invaders. The phagocytes include, by the way, neutrophils, monocytes, macrophages, mast cells, and dendritic cells. Ultimately, mannose-binding lectin helps mediate first-line defense against invading microorganisms. Mannose-binding lectin also helps take out the trash. It binds to old or dying cells, identifying them for engulfment and destruction by phagocytes. Other lectins function within the innate immune system as well, and may play a role in self-non-self discrimination. The specific binding properties of lectins can often be put to good use. Jacqueline lectin from mulberry tree and lectins from the fungi Agaricus bisporus have an affinity for foreign glycoproteins on cancer cell membranes. They can be used to first identify the presence of cancer and then to deliver medication to cancer cells. These are some of the known white hat roles for actors in the theater of lectins. On the negative side, the black hats can be very, very bad. Most of them come to us in the foods we eat. Although all foods will contain some lectins, only about 30% contain significant amounts. Seafood, dairy products, and nightshade plants can be potent sources of lectins, especially when eaten regularly. The richest food sources of lectin proteins, however, are grains, legumes, and starchy vegetables, including wheat, rye, oats, barley, potatoes, peanuts, soybeans, kidney beans, and other legumes. Maybe you have heard of gluten. It's one big, bad lectin of the prolamine class. It is abundant in wheat, rye, and barley. Plant lectins appear to be part of the plant's natural defense mechanisms, conveying either bad taste or toxic effects to whomever or whatever eats the plant, including fungi, bacteria, viruses, and certain insects or rodents. Perhaps now we can understand why many of the proteins in grains may not be suitable for us. They are usually concentrated in the seeds of the plant as a defense to assure the survival of the next generation by making the predator, or us, sick, or by resisting digestion, or both. That is why grains and legumes, the seeds of plants, are so richly endowed with lectins. It is a protective mechanism. Immune lectins from one plant are fairly easily engineered for production by another plant through gene implantation to create disease-resistant crops. Monsanto's specialty. But there is a problem. Consider how lectins support seed survival. Raw seeds eaten by a predator may taste foul or cause gastrointestinal distress due to its specific lectins as a way of discouraging consumption. Other lectins may additionally provide resistance to digestive enzymes. So it is not surprising that many plant lectins are resistant to cooking and to our own digestion. They can be toxic and inflammatory as well, and they are ubiquitous in our food supply for as long as we continue to eat grains and grain-based foods. Lectins are powerful allergens and need not be swallowed to have an effect. Prohevian is an example. It has protective antifungal properties for the rubber tree from whose sap latex is made, and it survives through the manufacturing process that gives us latex rubber. It is, therefore, the principal allergen in natural latex rubber. Genes directing the production of prohevian have now been incorporated into some types of tomatoes to pass along its fungus-killing properties to the new plant and fruit formerly susceptible to fungal attack. The effect may be to simultaneously pass along allergenicity to tomatoes for many individuals who are sensitive to latex. In this way, genetic engineering of plants can catapult a native plant previously known for its low toxicity up the charts to become one infamous for its allergenic risks. Food allergies have become more prevalent over the last 20 years, too, rising to become a significant public health concern. The prevalence of peanut allergies has tripled over the last 10 years, now affecting 2% of the population, approximately 6.6 million people in the U.S. Much of the increase could be a result of genetic modification of our food plants, practices that force the introduction of allergenic lectin proteins from one plant to another. The problem is likely exacerbated by two other factors. Number one, a decline in micronutrient density in the foods we eat, and number two, poor food choices that expose susceptible persons to a high intake of allergenic lectins through greater use of processed foods. Lower micronutrient intake weakens the immune response, leaving one less able to detoxify potentially harmful lectins from fast food, boxed food, and preserved foods. Processed foods are often rich in materials wholly from or derived from the richest dietary sources of lectins. These include grains, of course. Of note, whole grains are richer sources of lectins, as lectins are present in higher concentrations in the germ and outer layers of the grain, including the bran. They include legumes, peanuts, soybeans, other beans, lentils, peas, nightshade plants, eggplants, goji berries, yes, goji berries, peppers, tomatoes, and white potatoes. Goji berries, by the way, make an excellent laxative if you eat enough of them. That might be an indication of their lectin content. Dairy foods, meaning cheese and milk, pasteurized dairy products, may be more allergenic because the heat of pasteurization destroys the immunoglobulin SIgA, which normally serves as an antidote to bind and neutralize lectins to some degree at least. And then, of course, there are nuts and seeds. And they're included here even though their lectin content is generally lower than most of the other high allergenic foods. But as we know, tree nuts can be deadly for some people. And peanuts are not nuts. They're legumes. Now, for an allergic reaction to take place, the allergen must enter the body. That is, it must be absorbed or it must sneak its way in through an unnatural gap in the intestinal lining. Unless, of course, you're Prohevian from latex. That can get through. That can affect the skin and get into the system through the skin. Eating allergenic foods, though, can cause such gaps, creating a leaky gut that may allow through undigested, undenatured food material, pathogens, yeast, as well as allergenic protein fragments and additional lectins. Now, certain lectins from grain and legumes are also known to feed certain strains of pathogenic bacteria, E. coli primarily among them. Growing colonies of pathogens increase the risk of a more severe allergenic response, or may trigger disease if they cross over the barrier of a leaky gut. Allergenic lectins commonly also inflame the mucosal lining of the intestinal tract. Gluten is infamous in that regard. The lining of the intestinal tract is only one cell thick. That delicate barrier separates our interior from the outside world. It protects the finely orchestrated formal dance of enzymes, proteins, lipids, nutrients, and innumerable other biochemicals inside the body from the wild disruption of untutored, unrefined, indeed undigested, and potentially evil gatecrashers outside the body. All the good macro and micronutrients we need, as well as countless billions of good and bad bacteria, toxic substances from food, and pathogens, hopefully just passing through, spend time traversing the tube running through us from mouth to anus. Time spent in that darkness should be from 12 to 24 hours, but may lengthen to several unhealthy days when diets are heavy in meat and low in fiber. The tube is designed to break down food and seek out its nutrients, kill off some of the pathogens. More than half your immune cells are found in the intestinal walls and lumen of the gut. They take delivery of some chemical waste and keep unwanted toxic trash moving along. No loitering allowed in the GI tract. That's how it works. Good guys are let in, bad guys are kept out in the tube to be hustled out the trapdoor as soon as possible. Lectin proteins in foods are everywhere and usually do not pose a problem, but in genetically susceptible persons, interactions of some of these lectins with the lining of the intestinal tract can damage cells. The process usually takes some time, from weeks to years. Why? Because the intestinal lining renews itself constantly. You can imagine the abuse it takes, facing a new flood of food and drink several times a day. To stay in one piece and keep functioning as it should, the intestine regenerates its lining, the epithelium, every 5 to 7 days. It is the most rapidly regenerative organ in the human body. If lectin damage outpaces regeneration, their effects may only create intermittent swelling of the lining and a consequent fattening and collapse of the microvilli that form the brush border of the intestine. This state can severely compromise nutrient uptake, resulting in a malabsorption syndrome if it becomes chronic. Early signs may be chronic digestive problems, often alternating between constipation and loose floating stool. As fats are poorly digested, hair and fingernails may become thin, dry, and brittle, indicating poor protein absorption. More severe reactions strip mucus off the intestinal lining, structurally damage cells of the lining, thus shrinking or killing many before they can be replaced. The more harmful lectin proteins are not affected by human digestive enzymes either. They often arrive in the digestive tract along with their own bodyguards of protease inhibitors, substances that stop your own protein-digesting enzymes from doing their work. Trypsin and chymotrypsin inhibitors in legumes and grains are an example. They stifle trypsin and chymotrypsin enzymes secreted from your pancreas. Lectins capable of doing damage may foolishly be recognized by the cells lining the intestinal tract, the enterocytes, as simple sugars. The enterocytes then unwittingly absorb the lectins, passing them out through the basal membrane of the cell. The lectin has now been moved from outside the body into circulation. The process is not benign in its effects. While passing through the cell, this foreign and biochemically active lectin may damage parts of the cell, weakening its vitality, inhibiting its functionality, or may even kill it outright. A weakened, shriveled, and shrunken cell, or a dead one, creates a gap in the intestinal lining through which pathogens and digestive debris may pass. A leaky gut has been created. A range of potentially harmful substances that are linked to cancer, cardiovascular disease, rheumatoid arthritis, lupus, and other autoimmune diseases are permitted to pass into circulation, and many of them are lectins. The immune system, with so many of its participants concentrated in the intestinal tissues, responds by producing inflammatory cell-to-cell messengers, cytokines, that scatter like Paul Revere to summon white blood cells, the leukocytes, and other phagocytic cells, and their immunoglobulins to fight the foreign proteins. In the battle that ensues, a variable number of enterocytes, those cells lining the intestine, may be destroyed by friendly fire. Phagocytic cells can use forms of active oxygen and enzymes to rip apart whatever materials the cell has engulfed. These merciless defenders of your immunity make their own superoxide radical, singlet oxygen, hydrogen peroxide, protein-digesting enzymes, hypochlorite, yes, that's chlorine bleach, and other digestive enzymes that break down a bacterium's cell membrane and punch holes in the walls of a virus, breaking it apart and dissolving its contents. It is a monstrous process on the microscopic level, and it can save your life. Millions of phagocytic cells can be on the scene, swinging, biting, swallowing, and shooting with all their might. They try to stay under control. They try to keep their oxygen-charged free radicals, bleach, and enzymes within themselves, and succeed mostly, but sometimes enzymes or free radicals can leak out during battle and damage healthy neighboring cells. The immune cells have now inadvertently damaged healthy cells that will be cleaned up along with those previously damaged foreign lectins, creating even wider gaps. The process can exacerbate the early stages of gut lining perforation into a major leaky gut syndrome. With the doors wide open, the high binding affinity of other lectins can collect and drag other sugars, proteins, and foreign substances into the body. The protective barrier has been breached, allowing harmful bacteria such as methicillin-resistant Staphylococcus aureus and E. coli and yeasts such as Candida albicans to enter. The degree of damage is usually reflected in the speed of onset of disease symptoms and the severity of the ultimate condition. The entire scenario is heavily reliant upon genetic cooperation, however. In other words, the person has to be predisposed to such difficulties. To make matters worse, lectins do not necessarily require a leaky gut to find their way in. As mentioned before, some food lectins can be actively absorbed by first bonding to receptors on intestinal cell membranes, to next be taken into the cell and transported across the basal membrane to enter circulation. They can then deposit themselves in distant organs. Some agglutinin lectins from beans, including the peanut, may eventually find their way to brain cells responsible for liberating and activating the neurotransmitter dopamine. There, they may move backward and forward along nerve cells like tiny elves playing games with your moods. We often think of dopamine as the love neurotransmitter, for it is always elevated to addictive levels in the early stages of a potential love relationship. That period when the new partner has no discernible defects, is perfect in every way. But dopamine influences more behaviors than just those flowering from passion. Dopamine provides the simple will to get up and do something, anything, and is needed for high-functioning executive judgment. Yet all abused drugs, from alcohol to heroin, increase dopamine, indicating that the neurotransmitter is associated with addiction. The anticipation of receiving any reward elevates dopamine, as does receiving the actual reward. Just thinking about something pleasurable, or becoming aware that one must pay attention for any reason, or be vigilant, increase levels of dopamine in the brain. Chronically high elevations of dopamine, however, are often witnessed in post-traumatic stress disorders as paranoia, and are seen in schizophrenia and psychoses. Going the other direction, low levels resulting from destruction of dopaminergic neurons in the substantia nigra region of the brain produces symptoms of Parkinson's disease. Lectins and agglutinins from grains and legumes can modify secretion, uptake, and the effects of dopamine in the brain. Agglutinin lectins from green peas and wheat diminished dopaminergic activity, although other bodily effects from them were undetected. Wheat agglutinin also shrank the size of dopamine-producing cells, as did the lectin concanavalin A from the jack bean. Lectin from Griffonia simplicifolia simply reduced the number of cells. The study alluded to here was published in 2016 and conducted on roundworms, but is nevertheless significant, for roundworms have a well-characterized neuronal network that includes a simple dopaminergic system. They provide an excellent platform for the study of the impact of dietary substances on brain cells and dopamine. The implication of recent early studies is that lectins may be involved in the onset or progression of Parkinson's disease, because Parkinson's disease is characterized by progressive motor impairment attributed to a matching progressive loss of dopaminergic neurons in the substantia nigra. Deep in the body, then, lectins can cause problems ranging from food poisoning to death, perhaps Parkinson's, in genetically predisposed, sensitive individuals. They can bind to liver, bone, muscle, and other organ tissues, triggering immune responses that lead first to chronic inflammation and later to many of the diseases of affluence, contributing to diabetes, for example. In the young, lectins at high intakes can adversely affect growth and maturation. Lectins from grains and legumes are implicated in almost all disorders of the digestive system and the resulting nutritional problems. Their binding action ignites a series of harmful local and systemic reactions, firmly classifying the lectin proteins as anti-nutritive toxic substances. Locally, they can affect the turnover and loss of gut epithelial cells, damage the epithelial lining of the gastrointestinal tract, interfere with nutrient digestion and absorption, stimulate shifts in bacterial flora, and modulate the immune state of the digestive tract. Systemically, their penetration into the body and attachment to tissues disrupts lipid, carbohydrate, and protein metabolism, promotes enlargement and or atrophy of key internal organs, and alters the hormonal balance and immunological status. These potential disruptions dive right to the base of human biochemistry, altering how the human body works and whether it can survive. I hope I have driven home the seriousness of allergens, which are synonymous with lectins. Are we doomed, you may ask? Not quite. Food processing can significantly reduce the risk. The lethality of lectins, enzyme inhibitors, and other anti-nutrients in foods can be reduced by soaking, germinating or sprouting, fermenting, boiling in water, or pressure cooking grains or legumes. Using mineral-rich water in the process improves the effect, by the way. Yet the addition of microbial enzymes seems to be the most efficient method to reach complete degradation. Think natto, microbially fermented soybeans, as the poster goop for this process. So you've got to love those fermented foods, and protect yourself by avoiding or shrinking your consumption of lectin-rich, allergen-rich foods, grains, and legumes primarily. And pay special attention to peanuts, even if they seemingly give you no problem. I will close with this bit of information. I like peanuts, although they put me to sleep if I eat them with raisins. That should be a clue that something is wrong. But I really think I will pass on them because there is something else in peanuts just as deadly as the most severe peanut allergy. You may be expecting me to mention carcinogenic aflatoxin produced by Aspergillus flavus or Aspergillus parasiticus, which is a common contaminant of peanuts and grains and has been found in even the top brands of peanut butter. Although that's pretty bad, the deal killer for me is a lectin protein called peanut agglutinin, or PNA for short. It is a galactose-binding lectin whose receptor, the TF antigen, is more numerous on clusters of fast-growing malignant and even benign cells lining the colon. It also stimulates cell growth in its own right, meaning it can accelerate tumor development as well as the growth of normal cells of the colon. But how can you be sure that every cell in your colon is absolutely genetically perfect? And what if peanut agglutinin finds its way through a leaky small intestine, getting into your circulation, later hooking onto precancerous cells or microscopic foci elsewhere in your body? We all have them. Results could be catastrophic, as they were for our secretary at a previous place of my employment. She always had peanuts as part of her lunch. Cancer took her well before her time. Is there a way to protect against the proliferative effects of peanut agglutinin? Yes. Don't eat peanuts or peanut butter, and do eat fiber-rich vegetables. The binding of peanut agglutinin to the abundant TF antigens on tumor cells, which promotes cancer development, can be inhibited by galactose-containing vegetable fiber. The fiber's galactose competes for the lectin's binding sites, blocking the proliferative effect of peanut agglutinin. So eat more fresh veggies and save peanuts for the squirrels and raccoons that might visit your backyard. But if you wonder whether or not a food is troublesome to you, there is a way to check for yourself without spending a fortune on sophisticated allergy tests in the doctor's office. You can test yourself at home with a simple technique called the pulse test. Allergenic foods customarily raise your pulse rate. To check for that kind of reaction in yourself, simply eat a single food on an empty stomach. Wait 30 minutes and check your pulse rate. Repeat at 60 minutes and again at 90. If you come close to 100 beats per minute, or exceed it at any of those times, you may want to avoid that food. And that little final piece of advice brings to an end webinar number 3. I apologize, but this webinar has been a rather lengthy one, and consumed our allotted time for questions today. If you do have questions, please feel free to email me at mtimon, that's T-I-M-O-N, M-T-I-M-O-N, at vibranthealth.com, and I will get back to you as quickly as I can. Thanks for tuning in. You can wake up now and have a great rest of your day.